Alright, this is the second part of the video where we actually look at the Little Man computer. If you remember in the previous video, I showed you a diagram of a little guy ran around a room, fetching instructions, decoding them and executing them. And I wrote some code that showed how to add up two numbers. Now this is the code here, and it's written in assembly language. Assembly language is a low-level language. If you've been learning how to program in things like Python and things, you've been learning how to program in a high-level language. Low-level languages are far more basic. You have to do a lot more sort of coding to get the same sort of output that you could get out of a single line in Python, for example. But the process is actually fairly easy to understand. So what we have here is our mailboxes. It's our RAM, okay, and here we've actually got 100 mailboxes. They go from 0 to 99. And we have our program counter, we have an input tray, and we have an output tray, and much like we had in the original diagram. So let's actually just run this program and see what's going on, and then we'll look at how we can extend this to add three numbers together. So we'll run this program, and what happens is the program is, first of all, the program counter is pointed to position 0, so it fetches the instruction from position 0. We'll slow this down a bit. And the next stage is to actually decode this instruction and execute it. So the execution says input is required, so I'm going to input a number. So let's do our original number, which was 10. And the value 10 is going to be carried into the accumulator. The next instruction is going to be fetched from position number 1. As it's being fetched, the actual program counter is incrementing, ready for the next instruction to be fetched. So we're fetching the current instruction from position 1, which in this case is 399. 3 represents the adding, and 99 represents the mailbox to get that data from. So we're off to go to mailbox number 99 with our, sorry, I didn't mean to say add, I meant to say store. 3 is store. So we're storing whatever was in the accumulator into mailbox number 99. Once that instruction has been executed, we fetch the next instruction. You'll see that program counter is already incrementing to position 3, ready for the next instruction. So we're going to get position 2, we're going to get the input instruction from mailbox 2. There we go, finally got it out. Okay. We're fetching it at the moment. We're about to decode it. So we've decoded it, and now we're executing that instruction. So we're getting our next number. So we're going to input the number 8. And that 8 goes into the accumulator. We then go and get the next instruction from position mailbox 3. And while that's happening, we're incrementing the program counter, ready for the next instruction. So let's speed this up a bit. So we're going to position 3, and we're fetching the instruction 199. 1 represents what to do, and 99 represents the mailbox location. So 1 in this case represents add. So we're about to get, if you look down here, it says add accumulator. Add to the accumulator the contents of RAM address 99. So we're off to fetch whatever's in mailbox number 99, which is the value of 10. And we're going to add it to the value that's currently stored in the accumulator, which is 8. So what we should see in the accumulator is a result of 18. So those two numbers have been added together, and we now have a result of 18. So now we're off to position 4, because that's where the next instruction is, which contains a value 902. And while that's happening, the program counter has been incremented. So we're off to get position number 4, which contains a 902. 902 basically says output whatever's in the accumulator along, well, basically this is a bus 2. Okay, so when that's done, we fetch the instruction, we're going to decode it, and now we're going to take 18 to the output tray. When that has taken place, we're off to get the next instruction, which is 5, in mailbox 5, which actually contains 000. We are incrementing the program counter to 6, ready for the next instruction. Remember, the computer, the CPU, doesn't know what the instructions are going to be, so it's just incremented it to position 6. It's about to get the instruction it's going to decode it as instruction register 0, address register 00, and basically that will tell the computer just to stop, to halt, and that is the program done. So we've added 2 numbers and the result is 18. So how do we extend this further into a program that can output the sum of 3 numbers? Whoops. So let's change this to 3. Okay, so we want to change the program to 3 numbers. Well, in the first one, where we added 2 numbers, we only had to store 1 number. So we fetched a number and we stored it once, then we got the next number, and then we could just add the original number that we'd stored. So to do that with 3 numbers, we'd have to store at least 2 of them. So let's modify this code and say, okay, let's input another number, and then we're going to store it into position number 98. Well, actually, let's modify that slightly differently. Let's go, we add that number. Once we've added the second number, we'll store that one. So we'll store that in position number 99, overriding the original number. And then we're going to input another number. And then we're going to add the new number, like this. So this is what we're going to do. We're going to store the number in the first number in position number 99. We're going to get another number, and we're going to add whatever we've just collected with the original number, and we're going to store it and override the original number that we had saved with the new total. We're then going to get the third number and then add that number to the one we've just saved. And then we're going to output the total and we're going to halt. So that's one way of doing it. So let's run it this way. We're going to run it a little bit faster so we can see what's going on. So we're going to input 3 numbers, and I'm going to keep them simple. I'm going to do, let's do 1, 2, and 3. Okay, so the total is going to be 5. So 1. Oh, sorry, the total is going to be 6, rather. So we put the value 1 in first, and we're going to see that it's going to get stored into mailbox number 99. Now we're going to get the next number, which is going to be 2. So we'll just wait for it to execute the command for inputting. So it's ready for the next number, so let's do 2. 2 goes into the accumulator, and what we need to do is find out what we're going to do now, which is, in this case, store. We're going to add 1, so we're going to go to mailbox number 99, fetch 1, and add it to the value that's in the accumulator. So now we get a value of 3. The next instruction is going to tell us to store the value 3 into position number 99. So we should see 3 being carried down to mailbox number 99. The next instruction is going to be, let's get the third number we want to add. So we'll wait for that command to be executed. There we go. So I'm going to put in the value 3. And then what we're going to do is we're going to say, right, grab the value. The next instruction, once we get this from mailbox 6, we're going to say, grab the value that's in mailbox number 99 and then add it to whatever's in the accumulator. So we're going to grab mailbox number 99, which contains 3, and we're going to add it to whatever's in the accumulator, which was 6. The next instruction is going to say, output that value into the output tray. So we're going to see 6 being carried over to the output tray. And then the final instruction is going to be halt. So we're just going to wait for this to finish, and we should see that it says program is halted. There we go. So that's one way of doing it. Another way of doing it would be to just store all our values first. It's not as efficient, but let's do that. So we're going to store the first value in position number 98. Then we're going to store the final one, the next one in number 99. And then what we're going to do is we're going to input the next number, and we're going to add whatever's in position number 98. And then once that's done, we're going to add whatever's in position number 99, and we're going to output. So we're going to input a number, store it. Input another number, we want to store it here in position number 99, so STA 99. Input another number, then add whatever our first number was to the third number we've just collected, then add the next number, and then let's see how that works. So our code has just changed slightly. and we're going to run this again. So we're going to just check with the same numbers 1, 2 and 3 to make sure the output is the same. This time I'm going to speed it up a bit more. So the first instruction says input number, so let's do it backwards this time. Let's go 3, 2, 1. The output should be the same. So 3 is going to be stored in position number 98, so we should see 3 going in here. There it goes. Next number is going to be 2 that we're going to put in. So we should see 2 in a moment being stored into position number 99. So we're going to see 3 and 2 being stored. There they go. And now we're going to get the third number. And once I press 1 here, what we're going to see is 1 goes into the accumulator. And then we're going to see 3 being added to 1. So we're going to see a total of 4. Then we're going to see 2 being added to the 4, giving us a total of 6. And then that will be output. So here we go. So next instruction is going to say fetch the data from position number 98 and add it to the accumulator. There we've got a total of 4. The next instruction will say fetch the data from number 99 and add that to the accumulator. So it will be 4 plus 2, which gives us a total of 6. And then the next instruction is to output the 6 to the output tray. And then the final instruction is to halt. So there we go. The program is halted. 2 ways of doing the same program, but you can see the process. It's exactly the same as the original video I showed you with the diagram. It's fetching an instruction, decoding it, and executing it. That is basically how all computers work. The fetch, decode, execute cycle. And that is a quick video to show you how you can write simple programs in the Little Man computer. Feel free to mess around with some of these extra programs here. So finding the maximum number out of 2 numbers is quite a fun one to look at. You know, that's about putting in 2 numbers and returning whichever one is higher. Have a play with it and mess around with the codes. You'll find the Little Man computer instruction set in a lot of different places. I would probably, just have a look at any website that has it, and you'll see that there are certain codes that you can use with the numbers that you can use, or the letters, and it tells you what they do. So have a little play around with it and see what kind of programs you can create.